What's up, Devin32 here. So I'm back. It's been a while since I made these uploads, but this year a lot of things have been lined up. So without further ado, let me just get into it. So in today's video, I'll be looking at a Leetcode problem. Started coding a bit at Leetcode last year, and today I'll be looking at the two-sum problem. So let me just get into it. So the two-sum problem, given an array of integers m and an integer target, return the indices of the two numbers such that they add up to target. So you may assume that each input will have exactly one solution, as you may not use the same element twice. You can return the answer in any order. So you can see the example here. They've given us the input and the output. So you are supposed to add up the two numbers and so that you can get the target which they have stipulated on the screen. So in this first example, you're seeing an array of nums 2, 7, 11, and 15. The target is 9. So the output is the element at index 0, the number at index 0, and number at index 1. So if you add 2 and 7 together, you get 9. So there are three ways of solving this problem. So the first solution is you use n raised to power 2 time, or O1 space. You can use two for loops to loop through the array and find the indices of the two numbers that add up to the target number. So the first one you can see on the screen, we are looping through the list of numbers. So for each number, we are looping through the list again, starting from the next number. If the sum of the two numbers is equal to the target, we return the indices of the two numbers. So I'll pin the source code of this. It took me a while to figure out how this thing worked. But I was able to figure it out. It was quite challenging, but that's the first solution. Then the second solution is using on time. On space, we can use a hash table to store the numbers as keys and the indices as values. So then we check to see if the difference target minus number is in the hash table. If it is, return both the index of the number and the index of the difference. So the first step in the second solution, as you can see on the screen, we create a direct dictionary called values. We loop through the nums list. For each number, we calculate the difference between the target and the number. If the difference is in the values dictionary, we return the indices of the number at the difference and the difference. If the difference is not in the values dictionary, we add the number to the dictionary. So as you can see on the screen, I'll leave the link to the solution in the description box. So that's the second solution. Then the third solution, I just came across it. I was just working on it just to find different ways to represent it. So in the third solution, using on log n time, O1 space, you can use the two pointer method. After sorting the array and creating an array of the numbers and their indices, create two pointers I and j, where I is 0 and j is equals to length array then -1. If the sum is smaller than the target, increment I. If larger, increment j. If equal, return the indices. So this is actually quite complex. The first step is we first sort the list of numbers. We then use the two pointers, one at the beginning of the list and one at the end. We then check if the sum of the two numbers pointed by the two pointers is equal to the target. If it is, we return the indices of the two numbers. If it's not, we check if the sum is greater than the target. If it is, we decrement the end pointer. If it's not, we increment the start pointer. We repeat this process until we find the two numbers whose sum is equal to the target. So those are the three solutions I came across, and I just came across when I was trying to solve this problem. And they were actually just showing there's different logic to attacking the solution, and I thought of just making a video just to share it. So yeah, happy coding. See you guys in the next one.